Hello and welcome to another tutorial on effective Java, and we've already finished chapter 1 and now we're going to start chapter 2, which is about methods common to all objects. And you can probably guess that these are the methods that already are in the object class, which we know is the super type or super class of any other Java class. Enums are special in the sense that the way they are treated in Java are a little bit different than a regular class. But besides that, all the regular classes that you might write are basically they are derived from the object class. So if you don't extend any other class, implicitly your class will extend the super class, which is object. So if I go back and look at the object class again, object has a public constructor, and its main job as an superclass is first of all, it's not an abstract class, and there are good reasons why the developers, the people who created Java, didn't make this object an abstract or an interface, because sometimes, obviously most of the time, people don't really want to, if you make this an interface, all the methods are, at least in the beginning, right, until Java 8, all the methods are abstract, so the user has to override everything, which could be tedious, right? Now obviously now after Java 8, from Java 8 onwards, we have default methods, static methods, and even from, I believe, Java 11, we have private methods in interfaces. So maybe at this point, making the object class an interface or basically a purely abstract construct makes more sense, but I believe it's a good thing that object class is public. It has a public constructor, doesn't do anything, and object basically is a class that doesn't have any state by itself, right? It's an stateless contract for any other Java class, and it takes care of tracking the meta information of your class. So it has the get class method, which is a native final, right? You cannot override it. Basically most of the methods in object class are, you cannot override them, especially the ones for multi-threading, notify all, wait. These are all final. Get class is also final because you have to rely on the JVM to give you a consistent information, or basically a consistent class file for the meta information of your class. So you don't want the users to mess that up. Hash code and equals, obviously these are designed to be overridden if need be, and we will see that the first item in section 2 or chapter 2 of effective Java is about equals, right? Overriding this, and also the second item in chapter 2 is about hash code. So clone is also native by default, which does a memory copy of your object, so byte by byte. This is basically a shallow copy or raw copy. But then obviously the design of the clone was kind of flawed, so it's not recommended. And the other thing is that, interestingly, if you want to really override this clone, and it's a protected thing, so by default it's not accessible. You can promote protected methods to public, it's okay. And so you can override this, make it public so that the user or the client of your code knows that your class is clonable, but then you have to also mark it with a clonable interface so that the JVM also gets the hint, but it's more like so I mean, implementing clone is not recommended. There are better ways for making your objects clonable. The most straightforward one is providing a copy constructor, which is a much better approach than the clone method and marking with clonable interface. So obviously the ones that we always care about, especially in chapter 2 of effective Java, are equals, hash code. We can always override the toString, which is recommended, and the rest of the method in the object class we don't really care about. So back to chapter 2. Equals method, right? Item 10 says that obey the general contract when overriding equals, and this might seem like a very simple task, but in some cases overriding the equals method requires very special attention, mainly because of the inheritance hierarchy, and that's the one that is causing difficulties, especially that if some of the superclasses already override equals and now you want to specialize in the subclass, you have to be very careful in those cases. So object is a concrete class. It's not an abstract class. It's not an interface, right? So it's not an abstract class. So you don't really need to override any of the methods in the object class. At least they provide some sort of contract by default. But it is designed primarily for extension, which means that now obviously there are methods in the object which are final, which you cannot extend them. But the toString, equals, and hash code, these are the three main methods that are designed, intended to be extended or overridden. All of its non-final methods, such as equals, hash code, toString, clone, which is protected, and finalize, which is also protected and deprecated. So I highly recommend you don't touch finalize, you don't overwrite, you don't do anything with it. We discussed other ways of dealing with memory management, cleanup, resource management, etc. in the first chapter. So finalize will be removed eventually. Have explicit general contracts, because they are designed to be overridden. So they already provide some sort of explicit implementation. Now some of them are native. For example, hash code by default just goes to the JVM inside the C++ code of the JVM, gets the memory address of your object, which JVM already knows, right? References in Java are sugar coding the concept of pointers in C++. And then it returns the memory address. And actually it's not that simple. Hash code, if you look at the implementation, it's not directly the memory address, it's something else. We will look at it. The easiest way to avoid problems with the equals is not to override the equals method. So most of the time, especially if you're writing some sort of a package private class or inner class that are not really intended to be used by the client of your code, you most of the time, almost all the time, you don't really need to override the equals. So, and we know that the object class already provides a implementation for the equals, which just compares the pointers, right? The add memory addresses, you can think of it that way, or compares the references, right? Which in most cases that's enough, just comparing the references. In which case each instance of the class is equal only to itself, right? So if the default implementation in the object class, it compares the references or the pointers to your objects, and the only two objects that have the same pointer are one object, right? Two different objects which reside in two different memory locations in the Java heap cannot have the same pointer, right? So we compare the references or pointers. So any object, any instance of a class is only equal to itself, right? Is equal only to itself. And then there are, I guess, 4 cases where we don't really need to override the equals method, and the general contract of comparing references is good enough. The first one is each instance of the class is inherently unique, right? And these are the classes that normally don't have a state. So if your class doesn't have any state, maybe it's just a utility class that only has a static method. If your class doesn't have a state, even if you make the constructor public so that people can instantiate it, because the class has no state, all instances are pretty much equivalent to each other. So there is no point in comparing classes, instances of a class that doesn't have any state, right? So that's the meaning of this statement. Each instance of the class is inherently unique. There is no need for a class to provide a logical equality test. Sometimes there is no point in doing that, right? Another case is a superclass has already overridden equals, and the superclass behavior is appropriate for this class. So let's say we have a class that already overrides the equals from the object class, and then we extend it, but we don't add additional state to the object. We just override a particular method, for example. So if the state of object doesn't change, then the equality, the logical implementation of the equals method in the superclass is enough, right? Basically, two objects, we want to compare them or do a logical comparison based on the state of the objects, because again, if objects are stateless, there is no point in comparing them, because you cannot compare based on the methods, right? It doesn't make sense. The class is private, so the class is private, and or package private, and and you are certain that the equal. So if a class is private or package private, the client of the code, your user, is probably is not going to deal with them directly. So anything that the user or the client of your code is not going to be able to instantiate, there is no point in general to equals method override the equals method, because it probably the equals method will never be invoked, or at least will never be invoked by the client of your code, the user of the code. Obviously the developer might implement some sort of utility method or something that takes two objects of that class and then compare them. That's definitely a possibility. But if a class in general is private, is not part of the public API, there is no point in providing a logical equality, because the user of the code cannot directly instantiate them. So there is no point for the user to be able to call equals. Now if you look at the another thing that we can do is if we want to do a defensive programming or take a defensive approach in terms of making sure that some objects we don't really want to the equals method be called on them, you can override the equals method and just throw a runtime error, right? Runtime exception, not a compile time exception. You want to throw a runtime exception, so that at runtime, if this equals method is called by default, then it's going to be it's going to throw a runtime exception, and that clearly tells you that okay, this equals method was called by mistake. This shouldn't be called, right? So this is called a kind of some sort of defensive programming, which means you throw some sort of runtime exception. Again, not a compile time exception, because then you have to propagate that, and the general contract of the equals method in the object, it really doesn't throw an exception, right? So it's better to adhere to that and just throw a runtime exception. All right, let's head to Eclipse and try to look at the object class again and look at the these methods that already in the object class. So here's the Eclipse. Let's create a new package. Let's call this item 10. And then what I'm going to do, let's open up the type object. So from Java Lang, let's open this up. And as we mentioned, the object equals, right? Note the contract, right? So the default implementation is very simple. It just compares the pointers or references, and even this works even when this object reference is null, because obviously if we are invoking the equals on this object, then this reference cannot be null, because inside the object this can't be null because we are already inside the object, but this obj can be null, and comparison with null is allowed, and for any this pointer can never be equal to null, right? So if I create a class, let's call this dummy, and I'm not going to do anything, so let's accept the original contract of the equals, and then let's create a main method. And in the main method, I'm going to say var d1 is a new dummy. And so we're creating a dummy object, and we're going to say sysout d1 equals null. Now obviously this has to return false because d1 cannot be null. We have already initialized that. So let's run this. And this returns false as expected. So what happens if we don't initialize this? So right now the var, it doesn't know what type this d1 is. So if we go here, and then what it complains now, it says okay, d1 is not initialized. So Eclipse is smart enough is that before using the object, you have to kind of initialize it, otherwise there is no point. Now by default, if you add it to the state of the object, and we know that in Java cyclic referencing is allowed, which is very cool. And then this is, I'm not allowed to use this here because this is not static. Let's create it, make it a static, and now this works. I can use it inside my static method, and by default this is null, right? When the object is loaded into the memory and all the references if they're not initialized, they are assigned null. This is part of the Java language specification. And if we say equals equals null, and then this also returns true. Yeah, so yeah, but then local references cannot be left uninitialized, so local references must be initialized. There is no point in having a local reference which is not initialized. Yeah, then you have to initialize it. Now you can initialize it with null. I believe this is fine. Yeah, you have to initialize it with something. It can be null or anything else, but note that I believe if we use var, this is going to complain because it doesn't know how to infer the type, right? Any reference, any variable reference in Java has to have a type, and the compiler has to be able to deduce the type. But null can be referring to any type, any reference type can be null. So we have to specialize or make it explicit, right? So to be more precise, var d1 equals null does not work because the compiler needs to deduce the type somehow. All right. So what about the hash code? We will look at the hash code in more details in the next item of effective Java. But note that this hash code is native, which is very interesting, right? So by default, this hash code has a native implementation, and it just returns the integer, and this integer is essentially the this integer is basically the pointer, right? What about the toString? What is the default toString? Note that what happens, it gets the name of the class, so it's in the meta information, and gets the name at integer to hex a string hash code. So what this does, it gets the hash code, so and then to hex a string, convert it to a string for hex representation. So what is this hash code by default? Again, this is the memory address, right? And then we get it. So if let's initialize this new dummy, right? And then if we do a sysout at d1, this by default, this calls the toString on object superclass. So we know what we expect, right? So item 10, so if you look at the information, the fully qualified name of a class is package hierarchy dot the name of the class. Note that inside JVM there is no dot. Inside JVM we have /, but in the Java in general, in order for them to differentiate them in Java, you always, or inside your code, you get dot, right? But if you are familiar with the Java native interface and how to call the C++ API of Java, you know that inside JVM, all the qualified name of the objects, the class path separator is / instead of dot. And this 4617C264 is the hex representation of the hash code. And again, the default implementation of the hash code is the memory address. So this is an integer representation, and then we can sysout integer to hex a string, and then d1 dot hash code. So when you call the toString on the object on a reference, by default, if you have not overridden it, it just returns the hash code as a string. And the hash code says that basically returns a hash code value for the object. This method is supported for the benefit of hash tables such as those provided by HashMap. The general contract of the hash code is so basically the integer need not remain consistent. So hash code usually depends on the state, and we said that the object class by default doesn't have any state, right? So they had to come up with some sort of implementation that makes sense. And the one that makes most sense is to return the address of the object in the Java heap, right? Okay, so back to the PowerPoint. All right, let's continue with item 10. And when a class has a notion of logical equality, and again, this is mainly tied with the state of the object, that differs from object identity. Identity here means that pointer, right? Reference, or where the object is actually is in the Java heap. Reference, pointer, equality, i.e. location, memory, and a superclass has not already overridden equals, right? Then it makes sense for us to override the equals and then provide a logical equality. Note that for value classes, these are basically wrapper classes like integers, float, double classes, right? These have simple state, right? And again, these are mostly about the primitive types. We just create a class that represents those primitives. For value classes, it's very easy because they usually hold some sort of data, and then it makes equality is very easy and it's very intuitive, right? So if I want to compare the integer classes, we just compare the underlying integer primitives that they represent, right? So the default implementation of equals in the object class, we already looked at it, right? So note the signature. The signature is very important, and the reason that is important is that you have to realize that it takes an object reference. And the default implementation, obviously, it's a reference or pointer comparison. If you want to override it, you have to adhere to this signature, which means you write public boolean equals, which takes object, not your class type. If you don't adhere to this, and instead of specifying object, you specify your actual class type, it's not a valid override. It becomes an overload, and it can cause confusion and mistakes and errors. So you have to be careful about that. Now, Java doesn't provide operator overloading for equals, and we know that any other programming language like Python and C++, they allow operator overloading. They definitely overload this equal when it makes sense. And Java doesn't provide this, so the default implementation, it just reference or pointer equality. Obviously, this makes more sense, this operator overloading, especially when you're dealing with strings. And in Java, the only way we can do it is just explicitly call the equals, right? Equals method on the string. It could be a good thing or a bad thing depending on how you're feeling about it, but in general, I think in Java it makes sense not to allow overloading even for strings. They could actually allow that, but now it's not allowed. So you have to call the equals method to just be consistent with other objects, right? Enums don't really need an override for equals method, and again, enums are kind of special things because they have to adhere to a very strict way. The way they are constructed, their constructor is always private. They can hold the state, but normally enums are not designed to hold the state. And general contract of equals method is very, very important, and you have to make sure that whenever you override the equals method, you have to adhere to these 4 contracts, right? And these 4 items in general called equivalence relation. And it's always recommended to use your IDE to start generating the overrides of these equals. And as you probably know already, whenever you override equals, you want to also override hash code, because overriding equals, think about it. What does it mean? It means that you are providing logical equality. Logical equality means you have different objects or instances of the same class and you want to compare them, right? And again, logical equality is always closely tied to the state of the instances of the class, right? To the states of the object. And hash code is the same, right? If I have 2 instances of the same class, which they have different states, ideally I want to have different hash codes, right? I want to be able to differentiate them based on the hash code. So it makes sense that whenever we have a state and logical equality is required, it makes sense that we also override the hash code. And hash code is also, the override of the hash code is also tied to the state. And normally it's best to use IDs. If you're using Eclipse, just right click, go to source, and then generate hash code and equals. It opens a window, a nice window, asks you which fields of the object of the class you want to select or include in the equals and hash code, right? But whatever you do, you have to make sure that your equals, the override of your equals, adheres to these 4 contracts: reflexive, symmetric, transitive, and it has to be consistent. Now, symmetric makes sense, right? If object 1 is equal to object 2, you want to make sure that object 2 is also equal to object 1. That makes sense. Transitive, object 1 equals object 2 equals object 3, then object 1 has to be equal to object 3. This is kind of like the transitive behavior of logical equality. It has to be consistent, which means that if you allow your class to be mutated, so it has a mutation in the state, as long as the state is the same, you want to make sure that the equals always returns the same value, because logical equality is tied to the state, right? For any non-null reference value x equals null must return false, right? So a non-null reference should never be equal to null. And this again adheres to the original object identity, right? Any object that is already constructed has an identity which differentiates it from null, and that identity is that its pointer or reference is not null, right? It cannot be equal to null, right? All right, so let's see what else we can say. So it's better to let the IDE, auto generate the equals method. There are also frameworks that allow you to annotate your class, and it automatically generates the equals overrides for the equals. I usually just use Eclipse IDE, right? This is the, for example, if I write a test class which has a state x, and then I say override equals and hash code, Eclipse automatically generate this. If I select that I want to include x in the implementation of the hash code and equals. Now, looking at the override of the equals, it gives us some interesting facts about these 4 properties of the equals contract and how Eclipse deals with them. So the general contract of equals method, which we said that it's equivalence relation, it has to be reflexive, which means an object has to be equal to itself. Now, obviously, the reference equality is always correct. But then if we override the equals, then the logical equality must be also correct, right? That's basically the first line in the equals that Eclipse generates. It just compares the references. Obviously, if 2 objects have the same reference, they're the same location in the memory, so they cannot be different because they're the same, right? So this returns true. So this is the first one. And this automatically handles null. It doesn't actually handle null because we immediately return with a true value, right? So we could add for example, else statement. But here, so the first is reflexive. Any object has to be equal to itself logically and by the pointer, right? By the reference. The second one is that a non-null reference, an object that is already constructed, it cannot be null, which means if this obj, which we are comparing the current object to it, it cannot be null. So basically, so if this obj is null, the first if statement fails, it doesn't return. But then we say that if it's null, we just return false, because this object, this pointer cannot be null because we're already inside the object. Second one is checks. So if the obj is not null, it's not and it's not equal to this, we go into the third if. It checks the class. So this is some sort of reflection. Unfortunately, that makes the code slower whenever you try to examine do some sort of reflection on the class, get the class, or use the instance of operator, for example. Because remember, the general contract of the equals is that it has to take an object, otherwise it's not override, it's an overload, and that causes problems, right? So we have to do some reflection on this obj type to check the types exactly. Now this gets complicated when you are inside some sort of a type hierarchy, because then you want to see, okay, do I want to logically create a case when my subclass can be equal to one of the superclass types or not? That makes difficulties, and you have to be very careful about that. So if all these ifs fail, and then we know that the obj is not null, and then the references are not exactly the same, and then the obj and this reference are of the same type, and now we get to eventually compare the state, because these are exactly the same, and then we cast the obj to the right type and then compare the states. And in this case, primitive integers, we can directly compare them with the equal, so no problem. If you have float or doubles, it's better to use the compare methods in the double and float methods, because floating point comparison with the equals is not recommended, because we know that floating points have some rounding errors, and they could result into wrong equality statement, right? So to recap, reflexive means any object has to be equal to itself. Symmetric means if this dot equals obj returns true, then obj dot equals this should return true. Basically, these two statements must be equal in value always. Transitive means obj1 if it's equal to obj2 and obj2 is equal to obj3, then obj1 must be equal to obj3, right? So if you have three objects, 1 is equal to 2 and 2 equals to 3, then 1 is equal to 3. Again, the premise here is that there is no mutation happening in the states of these objects when we're doing this, because we know that if the state is mutated, then equality can change value, right, in general. But that's the fourth item, which is about consistency. If a state hasn't changed, the logical equality should consistently return the same value, right? Because what's the point if it just randomly changes value? For any non-null reference value x equals null must return false, which is basically the second check that the Eclipse automatically generates, which checks if this reference that is passed to the equals method is null. If it's null, we just immediately return with false, because there is no point. And be careful that if we have a reference x equals other x works for integers types like byte, short, int, line, but don't use x equals other dot x. Remember, x here is this variable state, the primitive state of this test class. Don't use this exact equality for float and double, because they have rounding errors. So instead use the double dot compare or float dot compare, because they kind of deal with the rounding errors that the float and double types have. And the final hint here is that many classes, including all collection classes, depend on the objects passed to them obeying the equals contract. And the hash code, for example, hash map, etc., they don't have any default implementation. What they expect the user is that if there is a custom type or a custom class or a user defined class, it's the responsibility of that class to provide overrides or the correct overrides for hash code and equals. And again, IDEs make it very easy for us to basically do this kind of checks. So I hope you enjoyed this one. Please stay tuned, and I'll see you in the next one.